All right, so we're going to first start with a linear function. And that's going to be way delayed. Okay. So the basic form of a linear function is right up there next to the bold where it says linear functions f of x is equal to mx plus b. We should recognize that, right? Y equals mx plus b, slope-intercept form. Okay. A linear function when you graph is going to be a what? It's in the name. Line, right? It's linear. It's going to be a line. So we have an example of one that we're going to graph, and instead of trying to remember how to graph these using slope-intercept form, we're just going to graph all of these using a t-chart, like when you started graphing. And we are going to start by picking 5 numbers, 2 on either side of 0. So we're going to go -2, -1, 0, 1, and 2. All right. So in our t-chart, we are going to pick those 5 numbers, -2, -1, 0, 1, and 2. And what we're going to do is we're going to plug them into this function right here, the one that I'm highlighting, f of x is equal to 2x minus 7. And if you will remember, what is f of x the same thing as? Y. So technically, this equation is going to look like this. Y equals 2x minus 7. And what we're going to do is we're just going to take each one of those x values and we're going to plug them in and find its matching y value. And then we'll plot the points. Okay, so if I plug in -2, I'm not going to show all my work up there because I don't have the space, but I can do it up here on the board. So for the first one, we're going to just take where the x is, we're plugging in -2, and we're going to simplify that out. Okay, so 2 times -2 is -4. -4 minus 7 is going to give me what, -11? Okay, so do that for the rest of those ordered pairs. Plug it in, and let's get the matching y value. And then we'll talk about plotting the points and showing what this graph looks like. And then we'll talk about how to determine the domain and the range of the graph. Again, we're plugging in those points. We already did -2. I want you to do -1, 0, 1, and 2. I also have these guys up here on the cabinets that have their arms showing you how a lot of these graphs are going to look. We're going to take a look at all of these with the exception of the logarithmic and then a couple more. So we've got our linear, which is what we're getting ready to do. And you can see his arms are like this. They're in a line. And then we'll talk about our absolute values and quadratics and cubics and exponential and a few more. So if I plug in -1, what does that give me? -9. And 0 gives me -7. And 1 gives me -5. And then 2 is going to give me -3. All right. So we're going to plot these points. Now, some of these may be a little off of the grid because it's only a 10 by 10 grid. So like that first one, -2 and -11, we'll put it in its approximate position, but there aren't 11 marks here. So I'm going to graph the point, -2, 1, 2, 3, 6, 7, 8, 9, 10. Oh, I'm sorry. That last one is -11, so we can put it there. So that's where my first point should go, -2, -11. And then we're going to graph the order pair, -1, -9. And then we're going to graph the point 0, -7. And then we're going to graph the point 1, -5. And then the point 2, -3. And then once you put all your points there, then we want to connect the dots, obviously. And you can tell that this is going to be a line. I'll try to make it as straight as I can. And then we put arrows on either end to let us know that that function is going to continue forever in both directions. Okay, so a linear function, even though my line's not completely straight, that's the best I can do. Everybody ready? All right, so when we talk about the domain, we're talking about what x values my function is going to touch. All right, so if you look at it, it's a line, and so it's going like this, but it's going forever and ever in each direction, correct? So that means it's going to go as far left as it can go. It's going to get lower and lower as you go, but it's still going to go as far left as you can go. And then it's going to go as far right as you can go as well. So what would that domain be? All real numbers. And how do we write that in interval notation? Negative infinity to positive infinity. So that's my domain. Okay, again, x values, we're looking side to side. What x values does that function touch? And because of those arrows, it goes on forever and ever and ever. And then the range are which values? The y. And how does the y go on the graph? Up and down, right? So we want to see what all y values this thing touches in my function. Even though it's like this, it's going to go forever and ever up, and it's going to go forever and ever down. So is that going to touch all of my y values as well? Yeah, so what would the range be then? All real numbers again. And a lot of these are going to be all real numbers, especially your linear functions. Both the domain and the range will always be all real numbers. It will change as our functions change. But if it's a line, then you can just go ahead and say the domain is going to be all real numbers as well as the range. Is everybody kind of okay with that? All right. So the second one is what we call a constant function, where you have f of x is equal to some number b. That's the generic form of it. And I gave you an example that we are going to graph here, and that's f of x is equal to 3. But again, what do we know f of x is equal to? Y. So that I'm going to change that to y equals 3 so that I can look at it as I plug these numbers in. And we are still using those same 5 values. -2, -1, 0, 1, and 2. Now with this one, those numbers, -2, -1, 0, 1, and 2, they go in place of what? X. What is not in my equation? An x. So what this constant function means is that I don't really have anything to plug x into. So that means for every one of those x's, what would the y value be? 3. Okay, so it's going to be 3 for all of these. Because I don't have an x in my function or in my equation, that means all of my y values are going to be 3. And so then I want you to plot those points. It is still going to be a line. This is a linear function because it's x to the first. However, this is going to be a different type of line, a specific type, I guess is what I want to say. -2, 3, -1, 3, 0, 3, 1, 3, and 2, 3. And then I'm just going to connect those dots. Trying to draw a straight line, but it's not working very well here. You would think I could trace, but that's not working either. Okay. Putting the arrows on either end. So what we want to think about first is the domain. We're looking left to right for the domain. If it has arrows, that means it's extending forever and ever in both directions. So that means my domain would just be all real numbers. Okay. What about my range? What y values does it touch? Just 3, right? You notice how it's a straight line at 3? So my range this time is not going to be all real numbers because I don't touch any of these y values down here. Okay, none of those. And I don't touch any of them up here. The only y value I touch is constant throughout, and that is 3. So the way we're going to write that is just using brackets, okay, because it's equal to 3, like that. Kind of okay so far? All right, another linear function, but this one is specific. It's called the identity function. It's f of x is equal to x. The example that we're going to use is this one right here. F of x is equal to x, which means technically y is equal to x. And we're going to plug in the same 5 values. This way we get a couple on either side of 0. These are all also what we call parent functions. These are before we do any shifts to them, moving them left, right, up, down, shrinking them, stretching them. These are all what we call the parent functions. And if y is equal to x, if I plug in x negative 2, what is y going to equal? Negative 2. And if I plug in negative 1, y is going to equal, okay, same thing for each one of these, okay? X is what y is. We're going to graph that, and I want you to state the domain and the range for that graph. Remember, domain goes left to right. Range goes up and down. We always start at the bottom, though. If you'll notice when we graph it, it is still a linear function. It forms a line. These first 3 are all linear functions. It's just the second 2 have specific names to them. What would my domain be in this case? All real numbers, okay. And then what about the range? What would that one be? All real numbers as well, okay. Because we're at an angle, so we're going to touch everything going left to right and up and down, because that line continues forever and ever. Any questions so far? Yeah, you don't have to memorize these. We just need to be familiar with how they look, because later on in this unit, we're going to be doing the shifts, moving them up, down, left, and right. So you kind of have to have an idea of how they look so that we can make them move. All right, we're going to do a squared function, or what we call a quadratic. Okay, x squared. F of x is equal to x squared is what we're going to take a look at. I want you to do exactly the same thing. Take those 5 values. Negative 2, negative 1, 0, 1, and 2. And I want you to plug them in. Your equation is y equals x squared. And remember, whenever you're plugging in for x, the whole thing gets squared. If you're using a calculator to determine what the square is, make sure you put the negatives in parentheses with the square on the outside. And you can also kind of see what the quadratic should look like. It's going to be like this, kind of like a U. That's called a parabola. What do I get if I square negative 2? 4. And if I square 1? 1. And 0 is, and 1 is, and 2 is. Do you notice how a couple of my y values are the same? That means it's going to match on either side, okay? You have what we call an axis of symmetry that goes down the middle. Negative 2, 4, 1, 1, 0, 0, 1, 1, 2, 4. And then when I do it, I'm going to curve through. It's not a point, it's a curve. It should look like a U. And then it's going to continue forever on either side up. Now, sometimes with these, the domain is a bit harder to see because it looks like it's just going to go straight up. But as it goes straight up, what does it do? It gets further and it gets wider and wider, right? So think about your domain. If my graph continues to get wider and wider and wider and it's not going to stop, what would the domain value be? All real numbers. Think about taking those little arrows and straightening them out against the x-axis. It's going to cover everything. Okay, so the domain is going to be all real numbers. Again, so like I told you, most of these, especially the domain, will always be all real numbers. But here's where we have to pay attention for our range. If I'm starting at the bottom, do I touch any of these numbers down here? What's the first number I touch on my y-axis? 0. Okay, am I equal to 0 there? So we should start it out with a bracket and 0. And then it's going to go forever and ever and ever in that direction. So that's going to take me to infinity. So my range is going to start at 0, but it actually can equal 0. And then it's going to go all the way up. So it goes all the way to infinity. And remember, with infinity and negative infinity, we have parentheses always. Anybody have any questions so far? All right, I want you to try the next one. We got a cube function. Okay, a cube function. You have the arms up there that look like a cube, or he's showing you like this. Curve my arms. So it's going to be like kind of an elongated S when you graph it. So go ahead, plug in your 5 values, negative 1, 0, 1, and 2. We're going to cube them. So think about negative 2 times negative 2 times negative 2. What would that be? And do the same thing. And then try your domain and range on that one. We are using f of x is equal to x to the third, which means y equals x to the third. If I cube negative 2, I get negative 8. If I cube negative 1, I get and 0, positive 1, and positive 2. All right. So negative 2, negative 8 is here. Negative 1, negative 1, 0, 0, 1, 1, 2, 4, 6, and 2, 8. And so what we're going to do is you're just going to curve through those, but on either end we're putting an arrow because it's going to extend forever and ever. Whoops. So that's kind of what our cube graph looks like. And then go ahead and state what you think the domain and the range are. Remember, those things get further and further. And as you progress, they're going to get taller and they're also going to get wider. So what do you guys think about the domain for this one? If it goes forever and ever, what is it going to cover? All of them. And what about the range? Same thing? Yeah. Anybody have any questions so far? Ooh. This one's going to be slightly different because we have to choose some different values. Why do you think I need to choose different values? It's a square root, and I can't take the square root of a negative, can I? Also, what kind of numbers should I probably choose? Perfect squares. Otherwise, we're going to get a decimal, and those are going to be extremely difficult to graph. Okay, so we're looking at f of x is equal to the square root of x. So that's going to be y equals the square root of x. So I need positive real numbers that are perfect squares. I'm going to pick 4 of them. Because the other ones will be off my graph. What do you think I should choose? What's the first one? Smaller. 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 0, right? And then what's the next perfect square? 1, and then 4, and then 9, right? Those are all perfect squares. Those are the smallest we can get. What is the inverse of a square root? What's the opposite of square rooting something? Squaring. So we talked about the square graph. It looks like this. It's a parabola, right? However, when we're taking a square root, we have to think about, we can't use the negatives. So I want you to think about this. If I have my parabola that we just graphed, I'm just going to kind of sketch it right here. But I can't use the negatives, so that cuts out half of this graph. And then the inverse of it is going to basically flip it upside down. So it's going to, I'm going to show you kind of how it looks when we get done. That's not the way it should look. Okay, this is half of a parabola. But when we find the inverse, we basically flip it around. So it kind of looks, your graph should look something like that, like the green one when you get done plotting your points, right? Okay, so the blue is half of my parabola, but when I flip it, it turns into that green one. Let's take a look. What's the square root of 0? What's the square root of 1? And square root of 4? And the square root of 9? 3. So we're going to start at 0, 0, 1, 1, 4, 2, 6, 7, 8, 9, 3. Now, the only thing is, when we graph this one, can I extend anywhere here? Because what kind of numbers are those? They're all negative. Left and down are negative numbers, right? And we cannot take the square root of a negative. So this one has some restrictions on my domain. So when I graph it, I don't put an arrow at 0, 0 or past that because I can't go negative. The only place I put an arrow on this square root function is at the end, past the 9. So we're going to have to be a little bit more specific with our domain. Okay, think about your domain left to right. I cannot have any negative numbers because it's a square root. So what's the first number I reach in my domain? 0, and then I go forever that direction, which is going to take me to infinity. So this time my domain is slightly different. So it's going to start at 0 and it could equal 0. And then it's going to go all the way to infinity. I want you to try the range. What's the first number I touch with my y value? 0. And then is it going to get a bit higher and higher as it goes? Mm-hmm. So it's going to be from 0 to infinity. Okay. And again, it can equal 0. Anybody have any questions so far? Okay, that one we just have to be careful of because we cannot use any negative values because it's a square root and we can't graph an imaginary number. So therefore we restrict everything to the left that's negative. Ooh, cube root. We're going to have to be careful about what numbers we choose here as well. Can we do a negative cubes though? Yes. So we can think about our negative values. We just can't choose random numbers. We have to choose some cubes. So think about your first few cubes. First, you got 0, right? So that's 0. What's 1 cubed? What's 2 cubed? If I tried to do 3 cubed, is that going to fit on my graph? No. Okay, so this one is too big, so I want you to do those 3. So we're going to choose 0, 1, and 8, but what else could I choose? -1 and -8, yeah. So we're going to go positive and negative cubes here. Again, we're graphing this function. Because we can do cubes that are negative, we're going to choose both the positive and negative cube roots that we decided on. Or perfect cubes, I guess. Not cube roots. So think about the cube function. It looks like this. So we're going to invert it. That's what this inverse is going to look like. You'll be able to see it better once you get your points and graph them. See how that was flipped around? Because taking a cube root is the opposite of cubing something. Do you remember when we found inverses, what did we do with our x and our y's? We switched them, right? So that's essentially what's going to happen here in our graphs. What's the cube root of -8? -2. What's the cube root of -1? Cube root of 0? Cube root of 1? And cube root of 8? Okay. So graph those points. If you'll notice, I'm just putting them up here so you can kind of see. These are inverses of each other. So didn't I take and switch these two to get that one? Yeah. And these two switched to get that, even though those don't really matter. Those switched, and then again, those switched. So that you can kind of see that they are inverses of each other since we've just talked about inverses. So 2, 4, 6, 8, -2. So do you kind of see how that graph is kind of flipping around a little bit? Okay. So what would your domain be on this one? All real numbers, because I don't have any restrictions on the negative parts. And then even though it may not look like it, what would your range be? It's going to continue to get taller and taller and smaller, right? So it's going to be all real numbers again, yeah. I prefer you to write an interpretation. All right, do the next one. What is the next one? Absolute value? Do the absolute value. Choose your -2, -1, 0, 1, and 2. Those don't need any special numbers because they're not squares or cubes. Plug your numbers in, plot your points, look at your graph, determine your domain and your range. And if you finish with this, go ahead and you can get started on that last one there using the same 5 values, except for that last one's going to be just a little trickier to graph because you're going to have fractions. So you just got to get it as close as you can. It's not going to be exact, obviously, because it's fractions. And with an absolute value on your graph, look at the two, compare them. Do you see the absolute value next to the quadratic? Do you see how his arms are straight with the absolute value, whereas they're curved with a quadratic? So with an absolute value, it should be a V shape. It should not be a curve. The parabola is a curve, okay? The x squared is a curve, but an absolute value is going to be a V. It should come to a point. So when you graph it, it should look like a point, not a curve. What's the absolute value of -2? What's the absolute value of -1? 0, 1, and 2. Okay. Again, you see how you have some matching y values? That's because the absolute value is also going to be matched on either side of its what we call axis of symmetry. And again, this one is an actual point. Ooh, that was ugly. Think about your domain. Those arrows go forever and ever to left to right, so that's going to be all real numbers. Is my domain going to be, my range going to be all real numbers as well? No. Start at the bottom. What is the first y value that graph touches? 0, and then it goes forever up, so it's going to go all the way to infinity. Anybody have any questions? Again, this is just so that we are very familiar with what each of these look like. It's not that we have to memorize them, but we're going to start talking about shifts and transitions, and we need to have an idea of what the graph looks like before we do that. All right, last one. Again, same numbers. This is what we call a reciprocal function. I'm going to pick my same 5 values. It's just I'm going to have to deal with fractions. I got to get it as close as I can. But there's something we need to talk about on this one too, though. If I plug in -2, I get a -1/2, right? And if I plug in -1, I just get, what about 0? Can you do 1 over 0 or 1 divided by 0? Okay. So that is undefined. Okay, so we're going to have to talk about that and what that means here in just a second. You can't graph anything that's undefined. What about if I plug in 1? I get 1. And then if I plug in 2? 1/2. Okay, so let's take a look here. Now, if it is undefined at 0, this is a particular case where we have to be very careful. That means here at the x-axis, I'm trying to highlight it in blue. My highlighter's just not thick enough. Okay, so here on the x-axis, should I have any points around here? X can never equal 0 because it is going to give me an undefined function. So that means my graph is not ever going to touch that x-axis. So let's start with the negatives. -2 and -1/2. Where's that going to, let's see, -2, -1/2 is just like in between, right? Let me make my graph a little bit bigger so I can see. So about, if my pen would write, about right there. Is that -2, -1/2? Okay. What about, -1, -1 is here. +1 is here, and +2, 1/2 is here. Ah. Well, that's kind of hard for me to tell what's happening, right? So let's do one more number on either side. Let's do -3 and +3. Let's add those to our graph. Okay, we're going to add +3 and -3. One over +3 is just 1/3, right? And 1 over -3 is a negative 1/3. So again, we're going to do as best as we can. 1/3 is just a little bit closer to 0. Stop. It's not letting me put my point. Ugh. There we go. And then 3 1/3 is just going to be slightly above. Still very hard to see what's happening, right? Let me ask you a question. Let's go back to our function. I'm looking at this one right here. Is there any number that I can plug in for x that will result in 0 for y? Is 1 divided by anything equal to 0? No, right? So not only can we not touch the x-axis, guess what else we can't touch? You can't touch, I said those backwards. Not only can we touch the y-axis, we can't touch the x-axis either. So when we graph these, what we're going to do is we're going to get real close to that x-axis, and we're going to curve through these points, and we're going to get real close to that y-axis, but we will never touch them because I cannot ever equal 0. X can never be 0 anyway. And then I can't divide 1 by anything to have it equal 0. So that's going to get closer and closer and closer, but it's never going to touch. Let me ask you this. Let's pick a big number. What if I chose 100 and I plug that in for x? Not that that's going to be on my graph, but that just gets a smaller number, right? If I did 1 over 1,000, that's even smaller. But I can't ever equal 0 no matter what number I plug in. So it just basically approaches 0 on either direction. It just cannot touch 0. And then the same thing on the other side. We're going to get close to our x-axis. We're going to curve through these points, and we're going to get close to our x-axis, and we're going to put our arrows. And that's kind of what a reciprocal function looks like. It's mirrored on either corner. And this one, our domain and range, is going to be a little trickier. Start with your domain. Left side. I'm going to go as far left as I can, right? So what would that be? Negative infinity. And then I go up to, what can I not touch? 0. So the first part of my domain is going to be from negative infinity to 0. Can I equal 0, or should I use a parenthesis? Parenthesis. And then I have a skip in my graph, so we're going to do our union like we've been doing. And I'm skipping over. I still can't touch 0, but then I'm going to proceed to go where? To positive infinity. So I'm going to use a parenthesis again and 0. So basically, x can be anything except for 0. Well, just say all the y's. Is that going to be the same? Y can be anything but 0. So your range is going to look just like your domain here. It's going to be from negative infinity up to 0, but we can't touch 0. And then from 0 to positive infinity. That's probably the hardest graph to deal with, okay? So we won't deal with it a lot, but we just need to be familiar with what it looks like.